Okay, we're going to be looking at this question today. Using the formal definition of the derivative, we're going to try to see why the derivative of sine is cosine x using the formal definition. So I have the first here. This is the definition right here highlighted in yellow, and if you're not sure how I even got here, you can look at this graph here. Basically what happened is I took a value x and then I added h to it to get another value here, right? So then f of x and f of x plus h. And what I want to do is make h really small so the slope of the secant line approaches the slope of the tangent line. And you can only do that through the limit, and then this is the difference quotient. From there, I had to plug in what I know. The function is sine of x. That's what we're working with, so that's what I put it in. So this is where the magic, I guess, happens. Because with polynomials we can easily just expand stuff out, right? But this, it doesn't seem like we can at the moment. However, we can use this identity. If you remember this one, so this one is the one of the sum and difference formulas for sine and cosine. So we're going to be using this, given that sine, a plus b, right? Sine of a plus b is that. And in this case, our a is x and our b is h. So we're gonna keep continuing this logic down. And we have sine of the first term, cosine of the second term, plus cosine of the first term, sine of the second term, and then minus sine at the end, all divided by h. Alright, I'm gonna scroll this down just a little bit. Alright, so now we want to see where we can go from here. I see that two terms have sine of x, and then that's the only thing common in between among all three terms. So maybe I'll just do a quick rewrite just to make them next to each other, and then maybe it'll be more clear what I want to do with that. Alright, there it is. So now it seems like I want to factor this out. This is kind of these two terms, the sine x and the sine x on the second term and first. They kind of want to be factored out just to make it look a little bit nicer maybe. So let's see. Sine of x, and then cosine of h minus 1, and then plus the other term, right? And now it kind of seems like we're stuck here because we can't really simplify anything. But I guess it's kind of hard to see, but usually when you have something separated by addition, you can separate them just by splitting the fraction into two sums. So I'm going to write it like this. Maybe we'll see something here. That should be a C. I'm gonna write it like this. Maybe we'll see something here. We still kind of don't see too much. But the next step is, see, like, we're taking the limit as h approaches 0, right? Does sine of x change? It doesn't really, right? Does cosine of x change? No, it doesn't really. So we can kind of take them out of the limit, if you want to think of it like that. So let me just walk through the steps. Maybe you'll see it better. So first I'm going to show that I can just do the limit of these two, right? You can separate, or you can use one of the limit laws and just do it by addition, right? The limit of the whole thing can just be the limit of the sum of the limits, or yeah. Oops, did not mean to move that up. So now we can see this term and this term aren't really dependent on h approaching 0. We can kind of take them out almost like a constant because it's not dependent on h. So sine x, the limit as h approaches 0 of cosine h minus 1 divided by h plus cosine x limit h approaches 0 sine h over h. And this is where stuff becomes familiar because we learned in limits that we can easily find this limit we can find, and this limit we can find easily. this limit's actually 0, and this limit's 1. And maybe I have a video posted about why these are so, but just this is the fact. We can prove it using a geometric proof, but we're focusing on just what the derivative of sine is. So if we know this is 0 and this is 1, this whole thing goes to 0, doesn't it? And this thing is just 1 if we evaluate the limit. So if this is 1, it's just 1 times cosine, and we're just left with this. We're left with cosine. So does that means the derivative of derivative with respect to x of sine of x is simply just cosine of x. Oh, why did I put that in brackets? It doesn't need to be in brackets, okay? So I'm going to zoom out and look at the whole thing. Oh, that's kind of small for you to see. As you can see, we had to be kind of creative and see, instead of just like with polynomials, we can just expand it, but we can't with trig functions. We have to use an identity. Usually with finding derivatives of trig functions using the formal definition, we have to be creative and use a type of identity. So we have to use the sum identity for sine. And you can also use it to prove that the derivative of cosine is negative sine. You can use one of the sum and difference formulas to find it. So, and then we just went through. The critical moment happens here where we separate it into 2 parts, right here. And then also here, where we figured we can take it out, and then where we evaluate the limit right here. These are the critical moments. So, that's it.